Rational functions review. All right, rewriting exponents, expressions with positive exponents only. Negative exponents mean that whatever is attached to it is in the wrong location. So if it's in the top of a fraction, you put it on the bottom. If it's the bottom of a fraction, then you put it on the top. So technically, 3x squared to the negative 1 is a fraction. And this whole thing has the negative 1 on it. So this whole thing will move to the bottom. And it will become 1 over 3x squared to the positive 1. Well, to the positive 1, we don't usually write. We just write it as 1 over 3x squared. That's it. It's over. Number 2, rewrite the expression with positive exponents only. Okay, so it looks like the only negative exponent I have is on this a to the negative 4. That means that that piece will travel to the top of the fraction. So now on the top, I have a squared, a to the 4th, b cubed, and on the bottom, I have b squared. Well, the tops, the a squared times a to the 4th, you add the exponents, it becomes a to the 6th. And then you still have this b cubed over b squared thing, okay? So when you are dividing two things, you subtract their exponents. So this actually becomes b and then a 1 on the bottom. So our final answer is a to the 6th b over 1, and we don't need to write the 1 in the denominator. In number 3, division of rational expressions means that we multiply by the reciprocal of the second fraction, okay? So you need to flip this one over. Then you need to factor everything. So I'm going to go ahead and factor x squared plus x minus 22 to be x plus 11, x minus 2. And on the denominator there, I have a difference of two squares, dots. X squared minus 121 is x plus 11 and x minus 11. Times, flip this fraction, so 1 over 2 minus x. Now you can cancel things that are alike, top to bottom. I have an x plus 11 on the top, and that cancels with the x plus 11 on the bottom. I have an x minus 2 on the top, and I have a 2 minus x on the bottom. Those two have a special rule. They cancel to be negative 1. I like to put the negative 1 on the top and circle it so I don't forget to include it in my final answer. So on the top, I have negative 1 times positive 1, which gives me negative 1 on the top. And in the denominator, I have x minus 11, and that's it. Okay? If you wanted to check your answer, and this is a fun fact, you can store a value for x. I would use like a different letter, but that's okay. Pick something weird, like 17 or 5, a number that doesn't already exist in the question. Store it for x, plug that original into your calculator, plug the answer into your calculator. So what I would do here is I would go to my Inspire, and I would do 5 control store, and I'm going to use a, okay? Type in the original fraction. It just said a and I typed z. A squared plus 9a minus 22 divided by a squared minus 121 divided by, this is the original part, 2 minus a. I get 1/6. Okay, fine. See if that's the same as your answer. So control divide negative 1 over a minus 11. Do you get 1/6? Yeah, then you know you answered the question correctly. That means you're doing a good job. Okay, number 4, simplify. Well, it's just multiplication, so you're going to factor and cancel just like you did in question number 3. You're going to factor the numerators and the denominators. So the numerator here, a to the 4th minus b to the 4th, that's the difference of two squares, which would be a squared plus b squared and a squared minus b squared over What two numbers multiply to be 1b squared and sum to be -2? So think about the numbers. We know there's an a in the beginning of each set of parentheses. We know there's a b in the end of each set of parentheses. What two numbers multiply to be 1 and sum to be -2? I hope you're saying -1 and -1. Okay? Times a minus b on top. And on the bottom, you take out a GCF of a. A times a plus b. Okay. Now we can start to cancel things that are the same. Well, it doesn't look like anything's the same. Let's see. A squared plus b squared? No. A squared minus b squared? No. A minus b? Oh, yeah, I have an a minus b on the top and an a minus b on the bottom. But it doesn't look like anything else cancels. But what you didn't do was factor completely. A squared minus b squared is another difference of two squares. So if that's a plus b, a minus b, then I can factor that and cancel something else. Let's see. I have an a plus b on the top and an a plus b on the bottom. I have an a minus b on the top and an a minus b on the bottom. So now, left on the top, and a highlighter would be a good idea to bring to your test because I didn't cross that out. I crossed these two out. I crossed that out, crossed out, didn't cross out that GCF, and then I have an a plus b. So my final answer is a squared plus b squared over a. No, you cannot cancel an a. No, you may not. Do not do it. It is wrong. Again, you could go ahead and use your calculator to store values. Check that the original is equivalent to the expression you got as an answer. So what you could do is go in here. I'm going to clear this out. I'm going to store 5 for A. And I'm going to store 7 for B. And if I type in the original, which was control divide A to the 4th minus b to the 4th over a squared minus 2ab, a times b in the middle, plus b squared times, control divide, a minus b over a squared plus a times b. That gets me 74 over 5. Let's see if that matches my answer. Control divide, a squared plus b squared over a. I got 74 over 5. I'm doing a great job. All right, number 5. Again, it's division, so you have to flip the second fraction, but you're still factoring everything. So 36 minus x squared is 6 minus x, 6 plus x. The order does matter. Divided by what two numbers multiply to be 12 and sum to be 8. I hope you're saying x plus 6 and x plus 2. And then we flip the second fraction, so the x minus 2 goes on the top. And in the denominator, we're going to take out a GCF of x. So now I just have to cancel like factors. On the top, I have 6 minus x, and on the bottom, I have x minus 6. Those cancel to be -1. I like to write it on the top and circle it so I do not forget it. 6 plus x and x plus 6, those cancel to be +1. X minus 2 and x plus 2 cannot cancel. So it looks like I've canceled everything that I can. So on the top, I have left a -1 and an x minus 2. On the bottom, I have an x plus 2 and an x. So my final answer is -1 times x minus 2 over x times x plus 2. All right, number 6 is a rational inequality. Oh, my computer froze. Okay, so you want to first factor anything you can. So on the top, you can factor the difference of two squares, x plus 2, x minus 2. And on the denominator, you can't factor anything, so you leave the x, is less than 0. Okay, identify critical values. What numbers would make the numerator 0? X equals negative 2, x equals positive 2. And what number would make the bottom 0 if x were 0? So put the 0 in between there. This says less than 0, which means we're going to shade the negatives, okay? And it means we do not fill in the circles. We do not fill in the point. So we go to our calculator. We go to the graph. We type it in. Okay? And you can see right here, that's where negative 2 is. 0 is here. Positive 2 is here. To the left of negative 2, those y values are negative. To the right of negative 2, the y values are positive. Yeah? At 0, they're going to switch. So to the right of 0, they're negative. And then to the right of 2, they're positive. So right here, we have negative, positive, negative, positive. If you're not sure and you want to double check that you know what you're doing, go to the table. Oops. Let me do that. Control T. And you can see to the left of negative 2, it's negative. At negative 2, it's 0. Between negative 2 and 0, it's positive 3. Between 0 and 2, it's negative 3. And after 2, it's positive. So you can double check your values that way. This said I wanted to shade less than 0. So wherever you have negatives, you're going to shade in between. And then you have to state your solution set. You have to say that your answer is from negative infinity to negative 2, union 0 to 2. And then it's over. All right, number 7. Again, you want to start with factoring. 1 over x plus 2, x minus 2 is greater than 0. Figure out your critical values. What number plugged in for x makes the top 0? Well, nothing. There is no x in the top. Okay. What numbers plugged in for x in the denominator make it 0? Negative 2 and positive 2. Okay. Then go to your calculator and graph it. So I'm going to clear out what I have. All right. To the left of negative 2, my y values are positive. In between negative 2 and 2, the y values are negative. And to the right of 2, the y values are positive. So positive, negative, positive. This says greater than 0. Greater than 0 means positives. So we're going to shade that in. So our solution set is negative infinity to negative 2, union 2 to infinity. All right. Number 8. If you have Miss Newman, you get a common denominator. If you have Mr. Krause, you solve by what he calls elimination. You're going to eliminate the denominators. So let's do this 2 ways. We both use a least common denominator, which would be x minus 3. So if you are Newman, you're going to watch this part. If you are Krause, you're going to fast forward and watch what we do, okay? So Newman, you need a denominator of x minus 3. The only one that doesn't have it is the 2. So you're going to get an x minus 3 there. So you have 4x over x minus 3 is equal to 2x minus 3 plus 12 over x minus 3. So go ahead and set the tops equal. 4x is equal to 2x minus 6 plus 12. So let's see, 2x is equal to 6. X is equal to 3. Is x allowed to be 3? Look up at the top. No, the denominator cannot have x be equal to 3 because then it would be 0. So the answer is empty set. Go on to the next thing you need to look at. Krause's kids. You will multiply both sides of the equation by x minus 3. So they cancel here. This one stays, and they cancel here. So you have 4x equals 2x minus 6 plus 12. So 4x equals 2x plus 6, 2x equals 6, x equals 3. Can that work? No, because that would create a denominator of 0. Empty set. Okay. Number 9. First of all, if you have a quadratic in the denominator, you need to factor it. So we know that this is x plus 5, x minus 5. Okay? So we know that the least common denominator, no matter who your teacher is x plus 5, x minus 5. So the quadratic that you should get is x times x minus 5 plus 9 times x plus 5 is equal to 50. So we get, let's see, trying to squeeze this in here is going to be kind of tricky, right? X squared minus 5x plus 9x plus 45 is equal to 50. So x squared plus 4x, subtract the 50 over, so minus 5 equals 0. Two numbers that multiply to be negative 5 and sum to be 4 are positive 5 and negative 1. So x is equal to negative 5, and x is equal to positive 1. Can x equal negative 5? Look at the original. If we plugged a negative 5 in, we would get a denominator of 0, so I can't use that answer. Can x be 1? Yeah. 6, negative 4, those are both okay. So my only answer is 1. Okay, number 10. No matter who you are, we do this the same way. So first of all, this minus business between these two things, no, just make it plus negative. Then you won't forget to distribute. The least common denominator for number 10 is x times x minus 3. So the 5 over x minus 3 needs an x in the bottom and on the top. The negative 1 over x needs an x minus 3 in the bottom, so it needs an x minus 3 in the top. So now they should have a common denominator of x times x minus 3. On the top, we have 5x minus x plus 3. Simplify that to be 4x plus 3 over x times x minus 3. Okay? Number 11. We saw this dirty trick a bunch of times in our notes, so I'm hoping you see it right now. When you look at 2x minus 6 and 6 minus 2x, I hope that you think to take out a negative 1, to factor out a negative 1 in the 6 minus 2x, to make it 2x minus 6. Because now the common denominator is just what? Technically, I can put this negative 1 on the top. So the common denominator is 2x minus 6. So on the top, I have 3x minus 9, and on the bottom, I have 2x minus 6. Factor both of those. The top has a GCF of 3. The bottom has a GCF of 2. And then something magical happens. The x minus 3's cancel, and you get 3 halves. This one is an excellent one to use your calculator to check. Go to your calculator. The numbers 3, 2, 6, and 9 are in this question, so I'm going to use 11 for x, okay? Go to your calculator. Type in the original question with 11 instead of x, and I think this time you don't even need to store because it's simple enough, but I'm going to 11, and I'm going to store it for, I don't know, C, just to show you that you can use whatever letter you want. So control divide 3c over 2c minus 6 plus control divide. The original one was 9 over 6 minus 2c. I got 3 halves. Oh, I feel better about my answer. Yeah, you should. Okay. Number 12 says determine if x minus 5 is a factor of 2x cubed minus 11x squared plus 13x minus 44. Justify your conclusion. There are 2 ways to do this. You can go ahead and do out the entire long division. That would be fine. And then you would just say no or yes. Yes, it would be a factor if it did not have a remainder. No, it would not be a factor if there was a remainder. So we learned something called the remainder theorem. And the remainder theorem says that if you have a remainder when you do long division, then you can find that remainder by plugging in the root. The root for the factor x minus 5 is x equals 5. And then if you plug in 5 for x here, the value that comes out is the remainder. So if you get a number other than 0, then x minus 5 is not a factor. But if you get 0, then yes, it would be a factor. So we need our calculator. Two 5 cubed minus 11 times 5 squared. Yes, you could store 13 times 5 minus 44. I get negative 4. Because I get negative 4, that means that x minus 5 is not a factor. So no, x minus 5 is not a factor because, and there's 2 ways you could say it here. You could say when divided, there is a remainder, or you can say because f of 5 is not equal to 0. That's using the remainder theorem. All right, so number 13. If x equals 1/4 is a root, determine if x equals 1/4 is a root of the function. Justify your conclusion. Well, if x equals 1/4 is a root, then f of 1/4 would be equal to 0. Okay? So we have to figure out what f of 1/4 is. I would go to my calculator. I would actually store this time. So this time I would go ahead and say, doc B here. I'm going to store it for M. So 1/4 is stored for M, okay? And then go ahead and type in the function. So, what is the function? Hello, Newman. Pull yourself together here. What number is this even? I lost my page order here. I've got a quiz mixed in. I don't even know what's going on here. Okay, so 8m squared plus 34m minus 1 is 8. So, is 1/4 a root? No, because f of 1/4 does not equal 0. And this is by the remainder theorem. And I would cite that, remainder theorem. Remember from geometry, you're allowed to cite a theorem if you can remember it. All right, asymptotes. Easy part is the vertical asymptotes. Vertical asymptotes occur when the bottom is 0. So factor that, x plus 1, x plus 1. So the vertical asymptotes are x equals 1. The horizontal asymptotes, you need to look at the top highest power and the bottom highest power. If those match, then it is the ratio of the coefficients, 1 and 1. 1 divided by 1 is 1. Those are the equations of your asymptotes. Number 15, find the asymptotes. So in the denominator, you need to factor x plus 9, x plus 2, which means your vertical asymptotes are x equals -9, x equals -2. And then your horizontal asymptotes, you look at the highest power in the numerator and the highest power in the denominator. They both have coefficients of 1, so y equals 1 over 1, which is 1. 16, find the asymptotes of the function. Your vertical asymptotes are what makes the bottom equal to 0, so that would be x equals -3. Your horizontal asymptotes are take the highest power on the top and the highest power on the bottom. Their coefficients are the ratio of their coefficients are the asymptotes. So -2 over 1 is equal to -2. Those are your asymptotes. Now, domain and range. We did a lot with domain and range on day 2 with these functions. We talked about the transformations and all of that. Most of you will always default with the graph anyway, okay? The one that's easiest to look at, though, is the domain. Whatever makes the bottom 0, you say x cannot be that number. So dead giveaway here, x cannot be 1. The range, you're either going to look at your calculator or you're going to remember that vertical shift. The parent function is that they both are asymptotes of 0. So this function says go right 1, go down 2. So down 2 is y cannot equal -2. But let's look at the graph so that if you are in a pinch, you can figure this out. So I'm going to clear out my calculator. I'm going to go in here and let me zoom a little bit so you can see. We have, what is it, negative, and then a fraction, 3 over x minus 1 minus 2. And we looked at these together and we said, okay, clearly the vertical asymptote is at 1. Well, the horizontal asymptote you can see is down here a little bit. And it would only make sense for it to be -2, right? Because that's part of the transformation in the function. So y cannot equal -2. Number 18 says divide. So your natural reaction to this should be to try to factor. So take a p squared out of the first two, so that would be p plus 1. And take a negative 1 out of the second two, p plus 1 over p minus 1. So let's see, that's p squared minus 1 over p plus 1. Have we factored completely yet? No. So p plus 1, p minus 1 over p plus 1 divided by p minus 1. The p minus 1's cancel, and you're left with p plus 1 squared. Oh, that was easy. Yeah, it was. The other way to do it is using long division. If you did this using long division, you would get the squared version, which is, p squared plus 2p plus 1 with no remainder. Now, you can check by deciding if this is actually a factor or not. If p of 1 on the numerator works out to be 0, then you know it's a factor, and it should come out nice with no remainder. All right, now I'm hoping when you look at number 19, you know that you're going to have to use long division. So the problem is, when you look at this, you start to write it down and something is weird. So you say 2p minus 3 divides into, you start writing 4p cubed. Then you notice that minus 12 is next, and you feel scared about that. You need to put plus 0x squared. And then, oh, I wrote x. I meant p. Hello, Newman. Okay. Plus the 5p, then minus the 12. So our goal is to get 4p cubed to cancel. So divide 2p into 4p cubed would be 2p squared. Multiply 2p squared times 2p is 4p cubed. 2p squared times negative 3 is negative 6p squared. Subtract, so minus plus. The 4p cubes cancel, and I have 6p squared. Bring down 5p. 6p squared divided by 2p is positive 3p. Multiply 3p times 2p is 6p squared. 3p times negative 3 is negative 9p. Subtract, minus, plus. 6p squareds cancel. 9 and 5 is 14p. Bring down, negative 12. 14p divided by 2p is plus 7. 7 times 2p is 14p. 7 times negative 3 is negative 21. Subtract, minus, plus. What's that, 9? That's the difference. I have a remainder of 9, so plus 9 over 2p minus 3. Check to see if that should be your remainder. The root would be 3/2. Go to your calculator, Doc B, store 3/2 for p, 3/2 for p, and then type it in is, let's see, where am I? I'm in the wrong location, I'm sorry. Let's see, is 4p cubed minus 12, minus 12 plus 5p. Yeah, I should have a remainder of 9, so that's a nice way to check it. Great. All right, so far in Haley's volleyball match, she has put into play 37 of the 44 serves she has attempted. Find the number of consecutive serves she needs to put into play in order to raise her service percentage to 90%. So right now her percent is 37 out of 44, and we want to add a number to that and make it be 90%. You could write it as 90 over 100. You could write it as 9 over 10. Either is fine. I think you prefer 9 over 10. So here, because you have one fraction equal to another fraction, you get to cross multiply. So 10 times 37 plus x is equal to 9 times 44 plus x. Distribute. 370 plus 10x is equal to, I want to say, oops, 44 times 9 is 396. I was going to say something else. I'm glad I checked that. Plus 9x. I'm going to subtract the 9x over, and I'm going to subtract the 370 over and get 26. So 26. Check it. Is 37 plus 26 over 44 plus 26 equal to 90%? Control divide. 37 plus 26 over 44 plus 26 is 9 over 10. Yeah, nailed it. Move on. Working together, Sophia and Samantha can paint a room in 5 hours. Sophia can paint the room on her own in 8 hours. How long would it take to paint this? How long would it take Sam to paint the room alone? Okay, let's give her a capital first of all. Okay, so Sophia is painting at 1/5 per hour. Sam is painting at 1 over x per hour. And they're painting Sophia, oh, I'm sorry. They can paint together in 5 hours. I'm sorry. Sophia is painting at 1/8 an hour. Yeah? And they're painting for 5 hours, so times 5. So Sophia will paint 5/8 of it. Samantha will paint 5 over x of it. And together they're painting one room. So 5/8 plus 5 over x is equal to 1 room. The common denominator here is 8x. So depending on who you have, you're either going to get a common denominator or you're going to eliminate. Either way, you end up with an equation that says, let's see, that would be 8x. So 5x plus 40 is equal to 8x. So 40 is equal to 3x. So 40 over 3 is equal to x. And 40 over 3, is 13.3 repeating, which is 13 hours and 20 minutes. A third of an hour is 20 minutes. Okay. 22. If you have a monomial with a square root in the denominator, you need to multiply by that same monomial. So multiply by square root of 8x over square root of 8x. You can multiply outsides and insides. So 2 times 8 is 16. X to the 5th times x is x to the 6th. And then you've got y to the 9th. Over 8x, square root of 8x times square root of 8x is 8x. Simplify the numerator. First of all, square root of 16 is 4. Square root of x to the 6th is x cubed. So far you have 12x cubed square root of y to the 9th over 8x. You can simplify y to the 9th. Make that y to the 8th and y. So that becomes y to the 4th. So you have 12x cubed y to the 4th square root of y over 8x. Simplify. 12 over 8 is 3 over 2. X cubed over x becomes x squared. So your final answer is 3x squared, y to the 4th, square root of y, divided by 2. Number 23. When you have a binomial in the denominator, you have to multiply by the conjugate. The conjugate is the same numbers, just a different sign between them. So on the top, leave the 4 out front. Leave it's a monomial, leave it out front, don't distribute it. And on the bottom, you've got 4 multiplications. Rad 5 times rad 5 is 5. Then you have minus 3 square roots of 5 plus 3 square roots of 5 minus 9. Every time, if you use the conjugate, these middle terms will cancel. So I really have 5 minus 9 on the bottom. So I have 4 times the square root of 5 minus 3 in parentheses over negative 4. The 4's cancel, and I can put the negative on the top. So negative 1 times the square root of 5 minus 3. That's my final answer. In number 24, the I is a problem because an I is like having square root of negative 1. I equals square root of negative 1. I squared is equal to negative 1. So if we can get I squareds, we can substitute. So again, you want to multiply by the conjugate. 2 plus I. Just change the sign between the binomial terms. Okay? So on the top, I have 3 times 2 plus I over 2 minus I times 2 plus I. Well, that's 4 minus 2I plus 2I minus I squared. The middle terms cancel if you used the conjugate, so that's good. So 4 minus I squared. You have to know that I squared is equal to negative 1. So this is really 4 minus negative 1. So I have 3 times 2 plus I over 5. You can leave it like that. You do not need to distribute. Final answer.